All right, guys, so we have done derivatives very often, and this is the situation we consider now. Many of you come to the class later than it's scheduled, so not at 6:05, but later, and maybe you miss a problem. You don't know what was the problem, but you catch the solution. So blah, 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 the derivative it ends up being 2x. And you want to write what was the problem. You understand? You have the solution, but what was the problem? If the derivative was 2x, what was the original function? What do you think? Derivative is 2x. What was the original function? You can see here, the original function might have been x squared, correct? Derivative, just because you are so familiar with derivatives, you know, taking derivative of x squared will produce 2x. Or it might have been x squared plus 5. Or it might have been x squared minus 7. Or in general, you might have expected x squared plus c. Clearly, taking the graph and adding c means you are shifting the graph up or down. That will not change the slopes, because slopes are just how steep it is, not really where is this graph located. Make sense? So x squared plus c is your best guess of what that function might have been. Good? So here we are going to play the game of guesses. Okay, guys, are you ready? A, help me guess. What is the original function to the best of our ability if the derivative is always equal to 7? At any x, the derivative is 7. Okay, that's pretty beautiful that you went so fast, but is it the most general? Maybe 7x plus something, plus c. Good, right? Plus 5, plus 7, because the derivative of constant will disappear. You just take this graph, look at it. This line has the same slope as a line above it that's parallel and a line below it that's parallel. Yes? Now, exactly Nassim, exactly Alan. Okay, now what's the idea here? So you see, if the derivative, remember what's the derivative about? It's just, you're trying to describe geometrically a curve, and you're saying that it's built of tiny line segments. I'm exaggerating those line segments by making them like this. Okay, I just created a separation, but really there is no separation. Okay, so every tiny line segment has the same slope 7. So that means globally I must have a line. Do you agree? Whereas if the slope, if the derivative depends on x, it means that maybe I have some pattern like this. You see? Again, I exaggerated. If the line segments are very tiny, it would look like a very smooth curve. But the point is, you see, here is a line with one slope, here is a line segment with another slope, right? So every curve we picture as built up a chain of tiny microscopic line segments. Good? You're with me? That's very good. Okay, so you understand that when you see a constant slope, you right away think must be a line, because constant slope means that all the tiny line segments are aligned together. Isn't it nice and neat? So B, solve B please. Derivative is 3x squared. Tell me please, what is the original function? If the solution is 3x squared, what must have been the original function? Nassim, be careful. You mean something slightly different, right? Because yes, what you say would actually not would involve other x's. So you think of it, and you see, well, the 3 comes down when I use power rule, right? So you think this must have been x cubed plus a constant. And you see, all I do is, again, I just guess, because I know power rule will subtract something from 3, and we'll put the 3 below. Good, you see why it's x cubed plus c? Pretty simple, I hope. Now, next question is C. Please tell me what's the function if the derivative is x squared. Well, James, you went with another derivative. We have to guess what was the original function, yes? So the other way around, right? So we have the answer is x squared, but what was the original function? We differentiated something, we got x squared. What function did we have? Careful, Nassim, you mean something else. Alan, again, you took the derivative. We want to go the other way. David, very good. All right, so what you do, you simply engage in guessing, okay? Nothing more, we're just guessing. So let's do the guessing correctly. Are you ready? So how do I guess this? So first, you might say, if the power is 1 unit above, when I take the derivative, it will drop to x squared, right? So I begin, I say, well, let me try to deal with x cubed, yes? But when I take the derivative here, I will get 3x squared, and there is no 3 here, right? So then I think, okay, what if I modify this problem and I add a 1/3? Now take the derivative. Remember, derivative goes through the constant, not bothering it, so that would be this. And they cancel each other. Yeah? Are you following, guys? So the answer is simply, the answer is x cubed times 1/3 plus any constant, because take the derivative of a constant, it will not change the outcome. Good? Let's see if you get this idea. You understand? All you're doing is, if you can do it fast, you can just guess and adjust your guess. Guess and adjust your guess. Now your task is this, is number D. The derivative happens to be x to the power of 5. What must have been the original function? Well, Christian, yes, kind of, but you're thinking of you be careful there, right? Let's do first D, and then when you say N, I wonder if you mean E, and then you have to be careful there. D, guys, what's the answer to D? Yes, Carolina, very good. So Nassim, again, you see the 2. You see this 2, yes? So you guess that the answer would be something like x cubed. In other words, x cubed will be, let's say this, that's the question. Take the derivative of x cubed. But when you take the derivative of x cubed, power rule drops the 3 and you have 3x squared. So what you do is you modify by multiplying by 1/3. You understand? Because you see, you begin with x cubed, doesn't work exactly. It works almost. You get 3x squared. So multiply it by 1/3. Take the derivative now. It's perfect, right? So what do we do with D? Some people ended answering. Yes, basically you are undoing the power rule. It's anti-power rule, precisely, Carolina, right? So x to the 5 means that we probably began with x to the 6, because that would produce x to the 5. But when I take the derivative, a 6 drops down. So you need to have it welcomed by an anti-6, 1/6, plus a constant, yes? You understand? Let's see if you can do it in general. If the derivative happened to be x to the n, what might have been the original function then? That's right, Christian. Very good. Well, be careful. Yes, okay, I see what you're saying. +1. Yes, I see. You just didn't put the parentheses. Good. And then plus C. Don't forget that. It's kind of not so important here, but it's going to be this. Yes, it's going to be 1 over n plus 1 x to the n plus 1. You see, because you drop it plus C. And of course, n plus 1, be careful, cannot equal to 0. So n cannot equal to -1. It works as long as n is not -1. Good? And then, of course, for f, the answer is obvious, right? If the derivative is e to the x, what was the original function? Very good, Carolina. Yes. And then just plus C. Don't forget that it might matter. Okay. So here again, I explained that in my notes. Do you, by the way, any of you ever read my notes? Like when the class is over? Yes, you do? I know maybe 2 people. That's guys, by the way, what you should do, right? You should read the notes. Right? That's why I wrote them. I didn't write them for myself. Okay, so read the notes. Hopefully they will save you, right? But if not, you know, the God, the Father. All right. Here are the questions that we are going to do. I hope my work is not in vain, right? And we will see how not in vain by how many of you will continue with me in probability in another college, and maybe with other mathematics, maybe extending these ideas, because we're not finished by far. No, I mean, but it's on the internet. It's Hunter. I'm more famous at Hunter, you know. Here I just teach calculus, nothing special. There I teach pretty much like anything I want. All right, so here, by the way, they also are nice to me, but who knows? After you ask for all the registrations, maybe they would say, well, this guy is not registering you well enough, and that's it. So here we have e to the power of 5. That's the derivative. What was the original function? Careful, guys. Always think about what is e to the power of 5. Well, careful, guys. Again, guys, before you kind of do anything, before you kick someone, ask yourself, yes, Brandon, right? Ask yourself, what is e to the power of 5? You see, when I say, look at it, look how good you are at this question. When I say, you know right away what I am, right? When I say moo, you know right away what I am. When I say, you know right away what I am. So why don't you see what is e to the power of 5? What is e to the power of 5? It is a number, constant, whatever you like calling it. I hate the word constant, but number is it right? Constant we can also use, but not, right? It just belittles real analysis. But the answer is yes, it's just multiplied by x. It's just a number, right? So e to the power of 5 times x plus c. This is a slope. It's a number, right? It's 2.71 to the power of 5, essentially, right? It's not the exponential function. It's a constant slope everywhere. Just the constant slope happens to not be equal to a number that you like, not 2 or 3 or something like that, right? It's pretty steep, and it's e to the power 5. Good? Okay, now your next challenge. Let's do it fast. Next challenge is B. B. Do B. To be or not to be? Come on, fast. Brandon, very good. There is I will show you in a moment how to do it slightly better.
Can I ask a quick question before we
Of
go to
course.
B? So you said that for A, we know it's a line because it's a constant, and then you just take that slope and plug it into the mx plus b formula. That's how you got the answer?
Well, I mean, yes, it's pretty much if it's a constant, then the original was a line. It's mx plus
Mm-hmm.
b, right?
Okay.
That's m, right? You can get it in all sorts of ways. You can imagine that if it's power 1, then 1 drops down and you get x to the 0. It's whatever you like to imagine. But I prefer when I see what's happening. Like, I want to know what am I talking about. Right? So if you do that, it always helps you. You would understand lots of complicated sounding theorems if you understand them truly their essence. You see, integration, what it is, it's all of it is not so difficult. So, what's the answer for B? What's more so? What's the question? You understand? The answer we have. The answer is 1 over x. What was the question? What was the original function? What did somebody try to differentiate? All right, ln, right? We know that we get derivative 1 over x when I use ln, but I should tell you, everybody is saying ln of x, but ln of x only works when x is positive, but here x could be negative. So the better solution is ln absolute value x plus c. Remember, we showed that when you take the derivative of ln absolute value, you get 1 over x in the instance where x is positive, but also in the instance where x is negative. Good? So the 1 over the ln of x is correct, but only if x is positive. Ln absolute value of x correct for all values of x, negative, positive, anywhere. Good? Next problem. Are you ready for the next challenge? Next is C. Please do C. X squared plus 5x plus e to the x. Find the antiderivative. In other words, find the question. All right, James, beautiful. 1 second, one small mistake, James. You mean 1/2 times 5x. Okay, so the answer is obvious. Yes. So the answer is x cubed times 1/3 plus 5 over 2x squared plus e to the x plus c. Everybody understands?
Can you just do the middle one quickly? 5x.
The 5x, you mean?
Yeah.
Well, think about it. 5x, right? I'm guessing what was the original function. So I think x squared, right? X squared. But if and then I can put the 5 here. The derivative of that will be 5 times 2. So I need to place a 1/2 here. You see, so what I do, what you can imagine, is very quickly modifying. Take, guess what might be the function, take its derivative. And then if it's not completely right, you can modify it slightly, right? You should remember that you can always, you're free to multiply by a constant, right? And that will not change much. Good. Now, your next challenge, derivative happened to be cosine. What was the original function? Very good, Carolina. And the answer is naturally, that should be too fast, right, guys? You just know that the derivative of sine is cosine, so it's sine plus c. Ln sine plus c. Be careful, right? And then the next is the derivative is sine. What is e? Help me with e. Okay, James, that's very good. Let's see, more of you. Exactly, right? So you know that if you take cosine, look at it how you think. If I take cosine x, derivative will be minus sine. So I put a minus, and that works. You understand why? Because I just think, okay, cosine. Derivative of cosine is not quite sine, it's minus sine. Multiplied by a minus, it works perfectly. F. Beautiful Nassim, beautiful Carolina, Rachel, Alan, very good. So the answer is just by guessing. I know derivative of tangent is secant, so the answer is tangent x plus c. Good? Tangent x plus c. Now, next line. Derivative is secant x tangent x. What is derivative is secant tangent? What is that? What's the function? Okay, good. 2 people. The rest of you? Good, Carolina. Wonderful. All right, we are ready with this, I think, yes? That is simply secant x plus c. Now, for the true challenge, are you ready for the true challenge? That's question H. Can you do that? What is the function if the derivative happened to be cotangent squared? That's challenging. All right, by the time I return, I want the answer. I'm back. Let's see what we have here. Let's do it now together. Let's see how we can do it. So cotangent squared. Here is what we can do, guys. So do you remember the trig identity cosine squared plus sine squared equal to 1? Yes? Secant squared is resulted from tangent, and cosecant squared is resulted from minus cotangent. But where is cotangent squared? If you take cosine squared plus sine squared, you will get 1. And if you divide everything by sine squared, you will get this relationship. Cotangent squared plus 1 is cosecant squared. Good? And the reason I did it is because cosecant squared is very easy to anti-differentiate. the antiderivative of cosecant squared is minus cotangent, right? Derivative of tangent is secant squared, right? Cotangent and tangent, they will have similar derivatives, just like cosine and sine have similar derivatives. The reason for that, by the way, because cosine and sine are the same shape curve, just shifted. You understand? So you always say there is a sine curve. You don't say there is a cosine curve. It's the same curve, right? Just you change your perspective, and cosine and sine are still the same thing. So here is what I have. I have that cotangent squared of x equal to cosecant squared minus 1. Good? And so the antiderivative of cosecant squared will be minus cotangent, and the antiderivative of 1 is minus x plus c. Yes? Plus a constant. When you take the derivative, it's this function plus a constant. Good? So there is one more problem there, I believe. Here it is. Problem number I. Could you please very quickly find the antiderivative for problem number I? All right, guys, ready? That should take very fast. Why? Because what is this function? This function is nothing more than, what is it? It's nothing more than x to the power of 3/2 plus x multiplied by x to the 1/2, which is x to the 3/2 plus x to the, sorry, not 3/2. I wrote this part. It's the cube root, so it should be the cube root. So it should be 2/3. Yes, and that would be 3/2. Good. Good. So then the antiderivative is what? The antiderivative is simply, I'll write it here. It's, I want to add 1 to this power, right? So x to the 2/3 plus 1 will be 5/3, right? So it will be x to the power of 5/3, and to cancel out the 5/3, I will put 3/5. Yes, plus 3/2 plus 1 is 5/2. 2/5. Yes, and then plus c. Good. So that's still a simple question. Let's do another one. Maybe less simple, and maybe not so bad. You see here is your function, guys. That's the derivative. Find the antiderivative. Don't remember, I'm not asking you for quotient rule. You have to reverse it. That's the result of a problem. What was the question?
Я там написал, а кого он собирается строить, а он только строит. У меня осталось только работать.
All right, are we ready? Could you tell me what you're doing? Yeah, but piece by piece, what is piece by piece? Okay, so here is how you can do it. Simply divide the t to the 4 and simplify it. So that would be 3 minus 1 over t plus 6, 1 over t squared. And now you have very simple pieces. That is 3 minus 1 over t plus 6 t to the minus 2. Yes, guys, you see that? Now the antiderivative of each piece are now very simple. It's 3t now. Antiderivative of 1 over t is minus ln of absolute value t. This will be minus 6t to the minus 1. You just add 1 and it becomes minus 1 and you drop it down. So that's why it's that, and plus a constant. Yes? As easy as that. Here are a few more questions, guys. So do A, do B, do C, do D. So let's do A very fast. Well, so we're doing A, guys. Let's see. 5x squared. How could I have gotten 5x squared? Well, what could I have done? It could have been 5 over 3x cubed. You agree? You all see how I can get this step. Now, how can I get derivative equal to 2 to the x? You know that derivatives of exponentials are very similar to the exponentials, right? So ln jumps in front. So it will be derivative of 2 to the x is 2 to the x ln of 2. So I guess that the answer will be 2 to the x, but divided by or multiplied by 1 over ln of 2. Because when I take derivative of 2 to the x, it will produce an extra ln of 2, which I want to be cancelled. 1 over x, the antiderivative of 1 over x is ln absolute value of x plus a constant. Yes? You understand? You see how I got the 1 over ln? Because the derivative of 2 to the x is 2 to the x ln of 2. So I want to greet it with 1 over ln 2 so that it will get cancelled, and I'll just get 2 to the x. Good? Now please do B. Fast. B. We need to finish those 4 problems, and then we can decide what to do next. Very well. Fu, you mean not tangent? Yes, good, good, good. So the answer for B is obvious. It is tangent inverse x. Yes? What about C? What's the answer for C? That's beautiful. So that's sine inverse of x, correct, Fu? So this, you just remember, it's sine inverse x plus C. And what's D? Does anybody recognize D? Antiderivative of this function is what? Secant inverse minus 1. That's right. So that is secant inverse of x plus C. Well then, that I suppose we will cover next time, but before we go, we will, or at least we can continue with office hours if you decide to stay with me. Let's do this round. Get ready. Let's see how good you are at those questions. If you want more, I'll show you more questions. Okay, ready? So if you haven't been here in office hours, let me explain what's the idea of this game. So there is a Russian game show for, well, it's for intellectuals. And yes, it's not like your, it's not Family Feud or whatever it is, right? It's so you have a people that are specially selected. You have to, yeah, who, what, where, right? Well, what, when, where, I think, but not who, right? Что, где, когда, what, where, when, I suppose, right? So in this game, those people, they some of them are part of this club for what, for 40 something years. Good. And the idea is this, and by the way, if you have a good question, we can send it, right? So the viewers send questions, which are then selected. If the question is good enough, it's placed on the game, and those people are supposed to solve it in 1 minute. Okay, here is an example of a question from that game. I can show you more if you're interested. Ready?
Пробуйте. Второй раунд. Уважаемые телезрители, хочу обратиться к вам с просьбой. Пожалуйста, присылайте в 13-й сектор вопросы, которые хотя бы вам самим нравятся.
He, by the way, says, please send to sector 13 at least questions that you yourself like. Don't just send garbage.
Вы же это делаете не для того, чтобы просто прославиться. Пусть это будет не 10 тысяч, а 100 вопросов, но хороших. Адрес 13 сектора, надеюсь, вы помните. 13. Прям такие, вам повезет больше. И вопрос даже не в сложности, на какие-то отвечают сейчас Брянск. Против вас играет Василий Житков из Брянска. Внимание, господа.
Attention, gentlemen.
2 кружки.
2 mugs.
Господа, перед вами 2 цилиндрические кружки.
Gentlemen, in front of you are 2 cylindrical mugs.
Одна пустая, вторая будем считать, что полная.
One is empty, and the second, let's consider it to be full.
Внимание, вопрос.
Attention, question.
Господин Низамов, через 1 минуту вам
Mr. Nizamov, in 1 minute,
нужно перелить из одной кружки в другую ровно половину.
you will have to pour from one mug to the other exactly half the liquid.
И объяснить ваш способ.
And explain your method.
Только постарайтесь не пролить чай на игровой
Just
стол.
try not to spill tea on the playing table. Here, if you're interested, I press pause, see if you can figure it out. And you can see afterwards the arguments that some of them have. You understand the question? So they ask questions of anything, riddles, poetry, you have to figure out. It's mostly type of, mathematical riddles, poems, anything, right?
You can't like add another item into this game, right?
No. You're sitting there. What you have is in 1 minute, you're supposed to pour half of this glass into the other and explain what's your method. And then you will show, so it have to be half of the mug, right? And then you will see what sort of why my brother, for instance, doesn't like the show, or in Russia you are easily berated. Like they berate you for, in Germany too. They make you feel bad. They're not, don't have this kind of niceties, right? So yeah, I'll show you. They always find what you don't do right. You see, if you do something, they say good boy. No, they just tell you what you're not good at. Yes, but and make room for that's a good Karolina. But how do you drink half? It's a very good. But how do you drink half? It has to be exactly half. Do you understand the question? You don't have any rulers. You don't have any instruments. It's you're sitting at the table. When you're ready, tell me that you want me to play, and I'll play. You're supposed to solve it in 1 minute. So you understand the people that are sitting at this table and the people that are in the club surrounding them, they're members of the club. And you have to kind of be very good to become a member of the club. And that's for life. You can go to the show forever. They were intending to make this show in America, buy it, but it never came about. Somebody said Americans are just not good for it. Okay, put 1 cup on top of the other and then flip it. But interesting. Okay, Pavel, interesting. Keep them tight. But you see, you have to kind of do it. So it's an interesting idea. Interesting idea what Pavel says. I like it actually. Okay. Yeah, Pavel actually had an interesting idea. Except, what do you do afterwards? You see, Pavel. Yes, maybe if you balance it again, how do you balance it exactly? Exactly horizontally, you don't have a balance, and then how do you separate them? But that's an interesting idea. Just hold it forever. Actually, I like Pavel is already kind of good. You can see. I wonder what this host would say to you, right? Yeah, so okay, guys, are you ready for the answer? Yes, I'll press play, and if you want to see afterwards another question, I'll show you another. I have a collection of the best questions from 2012, for example.
Да, это там что...
Ладно, давай,
нарисовать там до половины, да.
Вот так.
Чтобы край...
45 диагональ.
По диагонали.
Ладно, хорошо.
Это просто, я знаю, это...
Вот, ты покажешь, Ильдар покажет. Ильдар, сможешь показать?
Сможешь?
Понятно, ладно, еще как можно? Как можно?
How
Просто
else could it be
переливай там, допустим, сравнивая уровни на глаз. Уровни на глаз.
compared by eye?
Два треугольника у тебя получилось.
Triangle,
С помощью
triangle.
ручкой или наклонить кружку?
Прямоугольник, смотри, Кость, сечение прямоугольника.
Я знаю, наклонить кружку.
Ребят, а может быть ручку поставить в обе кружки,
Maybe
чтобы она точно
it's,
фиксировала
the
вот этот вот наклон?
hand
Ребят,
under
говорили,
the
что не цилиндрический, остальное не важно.
Да, цилиндр.
cylindrical,
Нет, только я про...
Чтобы у тебя
45-30. Именно 45.
вот здесь вот.
If you put at an angle of 45 degrees.
Сечение пополам.
Еще что-нибудь может быть, ребят? Ну,
Anything
вот,
else could be
ну с геометрией что-нибудь.
something with geometry.
Господин ведущий.
Mr.
Это, это была серия на 50 секунд, еще вот сейчас будет
Сейчас пока
минута,
Ильдар
да.
подготовится к этому.
Прошу, Ильдар. Ильдар Низамов.
Я постараюсь изобразить тот способ, который нам
I will try to represent this method that was
объяснили Никита и
told to me by
Женя.
Nikita and Zhenya.
Одну секундочку. Через
1 second.
1 минуту вам нужно
In 1 minute, you have to,
перелить из одной кружки в другую ровно половину и объяснить ваш способ.
from one mag to the other until it's half and explain your method.
Прошу, рисовать ничего не надо.
You don't need to draw anything.
Не будем ничего рисовать, будем переливать.
We'll-
Наклоняем пустую кружку на 45 градусов.
We leave the empty mug at an angle of 45 degrees, okay?
Берем вторую кружку.
We take the
Да.
second mug
Доливаем до кромки.
Да.
and pour until the rim.
До кромки чего?
До кромки
To the rim
пустой
of what?
чашки.
Это как? Ну, у вас все на
What
подносе
is it?
уже?
Условно вот
Filled
так.
already a bunch.
Так. И что получилось?
And
Мы
what did you
разделили
get?
ровно пополам. У нас
And then we
получилось...
divided half.
Ну, может быть, я сейчас чуть-чуть
Well, I spilled a bit.
неправильно доклонил, но в итоге у нас должно было получиться следующее. Мы делим...
Ну,
Here is what
теперь
it is.
нарисуйте, потому
And now you have to draw
что не очень у вас пролилось много,
because a lot of what you did
поэтому
spilled out.
оценить очень сложно.
В сечении кружка у нас прямоугольник, потому что нам сказали, что они
The section of the cup is a rectangle.
цилиндрические. Мы делим его
We divide it in half
пополам, ну, и диагональю. И
with a diagonal.
два треугольника у нас
We
получается
have two
равной
triangles
площади.
and we have equal area.
И распространение на объем, мы видим, что у нас объем тоже получается
And
равный.
then that would imply that volume is also.
А теперь, внимание, правильный
Now
ответ.
listen to the right answer.
Действительно, кружки цилиндрические,
All right, the mugs are
задача
cylindrical.
геометрическая.
It's a geometrical
Нужно,
problem.
посмотрите на экран,
Look at the
нужно
screen.
наклонять,
You have to lean,
только в другом порядке, нужно
aber in a different direction.
наклонять до тех пор, пока не появится краешек на кружке.
Until you see that the edges are connected by a line. You understand? It's that's what you do. Do you understand the answer? So, well, here you say they were right. Let's listen to what follows next. Okay, so listen to what happens, and I'll try to explain to you what it is about. Okay, isn't it cool?
Который вы льете. Вот будет ровно половина, но Ильдар показал то же самое, по-моему,
But Eldad showed, I think, the same thing. So,
господин Верхошинский, просто в обратную сторону.
Mr. Verkhoshinsky in the other direction.
Честная победа, 2-0.
It's an honest victory. So this guy and the next standing to them, they are all very old players. They have been there from the beginning, and they are lawyers, both of them. I guess pretty smart. Okay, so
Но, господа, после такого вопроса было бы странно. Да,
the
господин.
answer is incorrect.
Ответ прозвучал неправильно.
The
Неправильно.
answer that they voiced is incorrect.
Было сказано, что кружку надо наклонить на
It
40.
was told that the mug must be, those two guys is very mean, right? And they're in the same team. It was told that the mug must be leaned to 45 degrees.
5 градусов. Ответ неправильный.
The answer is incorrect.
Так.
Градус может быть любой в
The angle might be anything
зависимости от высоты кружки.
depending on the height of the mug.
И то, что вы рассказали, не имеет никакого
And what
отношения
you
к 45
narrated has
градусам.
nothing to do with the
Что
angle.
я рассказал?
Нет,
I answered.
ну вот то, что вы рассказали, правильный ответ,
But you
к
said it
45
correct.
градусам, о котором
But the
было
45 degrees has
упомянуто в
nothing to
ответе
do
за
with the
такого,
angle.
никакого
Has
отношения
nothing
не
to do
имеет.
with it. But they showed correct.
Итак, давайте посмотрим на рисунок.
And let's look at the
Кружка
drawing.
цилиндрическая, не 45 градусов.
It's not
Давайте
45
посмотрим.
degrees. It has nothing to do with 45
Ну,
degrees.
не 45 градусов, действительно, в этом они ошиблись.
In that they were wrong.
Господин Верхошинский, ну что, я считаю, что надо присудить победу
I
телезрителям.
guess that means that we must give the victory to the viewers. If you're able to give them a question that they cannot answer in 1 minute, you win money. What was incorrect? They say 45 degrees. It has nothing to do with 45 degrees. All you have to do is make the water touch diagonally, as was shown in the picture.
1-1.
1-1. And look at this, the begin argument.
Что нарисовал?
Господин Новиков, ну, если
Мистер
даже
Новиков.
старейшины считают, что нельзя принимать такой
The
ответ, что
elders
я
think
могу
that you
сделать?
cannot accept this question. Those two are, they were in the game forever.
На этом рисунке нет угла 45 градусов.
Господин ведущий, я прошу
Мы с
прощения.
господином Подошовым абсолютно
Прошу.
Me and this guy is a mathematician. You see, this guy is a very good mathematician. And he with Mr. Patashov, they think the answer is correct.
Я считаю, что считать вопрос
Как это два
можно
магистра считают нет, а мы два магистра вроде бы не
We are two magisters, and they're kind of they are what you call very good players, elite players. Say so. This guy is a mathematician. You can read about him in Wikipedia. Right? He's a
Два
very good
магистра
player.
считают, что правы, два
So they
считают,
think
что
it's
не
correct.
правы.
You see, so that's what happens. So even if you give an answer, they berate you. If you want, I can show you one more question, or do you want to do more math? What do you want to do? Another question? I'll show you very interesting ones. One more. All right, let's do one more, and then we'll decide. Here, ready? So those are collections of some very good questions. So I'll just do one and then you decide what you want. For 2012.
Господин Касумов играет Юрий Терлецкий, поселок Комсомольский, Архангельская область. Балаш, скажите, вы уже как
They always bully this guy. This host always bullies him. I don't know. You understand the question? You said, let me again explain the question if you need this, right? So he says, you see, this is a Russian shower. It's called banya. It's a sauna, right? You know what you do? You sit there and you have very hot fumes. And he says in the winter time, where it's very cold in Russia, he removes those planks. They are not hammered to the floor. So the floor, 4 of the planks can be removed, and they are removed every Sunday, right? Every Sunday. And his question is, why is it not hammered and why is it removed every Sunday? That's a pretty hard question, right? I could not figure it out at all, but who knows? If you want to, let me know if you want me to play. But you understand that? So you have to, the idea of the game, you have to very quickly come up with versions. In 1 minute, they have to figure out why he removes those planks.
How often do they go in the sauna?
Every Sunday. They do it once a week, but some of them don't know the tradition, right? So this guy, Balash Kasumov, is always bullied. It's like Balash Kasumov, right? It's like almost like you haven't been showering well enough or something. So he's bullying him all the time. I don't know, but he does it very politely. So you're not a true knower. You're not true knower yet, right? You're not like those two guys there, the snobs that are standing there. They're very good players, though. Those two.
I'm guessing it has to do with them using
Okay.
the sauna on Sunday. If it's
Yes,
very
maybe,
cold.
but in the winter, why me? Okay, moisture, but why is it open? Right? It's too bad if you have to go, Pavel. Maybe you have a good idea.
Maybe because if the water were to, I guess, like accumulate and seep through the cracks of the wooden planks, the wood would get heavier and turn out to be
Okay.
bad.
Well, I see you come up with versions. So the sauna could let pipes unfreeze. Interesting idea, Pavel. Interesting idea, Christian. You want me to press play? But you have versions. I mean, I truly did not know. I didn't answer this question. Right? Most of those questions you need to specially tray for it. Okay, so I'm gonna play it, and if you want afterwards, I'll give you another one. So they always have. You understand what it is for? So it's called. He wants to go fishing. So after he takes the shower, it gets warm. The worms are all around there, and that's where he digs. Yes, once dirt, right? Isn't it cool? Amazing. Let's do one more problem before we return to math, if you want to do it, because you have to be fans of that show, right? We have to understand what it is like, what we're striving for, right?
What's he doing with worms?
What is he doing with worms? Fishing, right?
Oh, okay.
Okay, let me play you one more, and then we can do the math something, because we have to be fans of that show now, right? Everybody has to play this show now. You see, I'm bringing And then I'll show you maybe, you see, so you understand what is expected value.
Каждое воскресенье хожу на рыбалку.
В субботу постановку. Внимание.
This is insane. You would not get it. I will skip it because you need to read Evgeny Onegin. If you haven't read Russian literature, you have no chance. So I'll do this one. Although it's a great question, honestly, very great question about theater. But if you don't know Russian literature for this question, you have no chance. Afterwards, if you're interested, I'll show you what it is. Okay, this one. The worth of any painting, like any work of art, is increasing with year after year. But we wait for a special occasion to destroy it. Question. What sort of painting is this? You understand the question? So there is on the wall a picture, and it says that we in our region obtain such pictures, and as you all know, the worth of a picture, like any other work of art, increases year after year. But we wait for a special occasion to destroy this picture. Question: what sort of picture is it?
This might have to do with the culture of Russia, no?
Well, then I would immediately know. You see, I mean, culture of Russia or not, I mean, even what you know, culture of Russia, they ask questions that if you don't, that even if you read books and you're familiar with literature, they're very difficult questions. Let's say I didn't guess the previous question that I skipped, but you would not have a chance if you haven't read certain books. If you haven't read Evgeny Onegin, you would have not have any chance. So you're supposed to know literature, you're supposed to know mathematics somewhat, but you're supposed to be very quick thinking, right? The best questions are, of course, those where you can figure it out.
Does it have to do with the material of the
That's a great, you see, Carolina, very good. You already, maybe with the material, maybe that's an interesting idea. See, what you do, guys, is you kind of quickly discuss ideas, and then you have to come up with a version. And if you do it in 7 minutes, that's great, because, you know, you can train and do it faster once you have enough. Any ideas? No?
Yeah, I'm guessing they have to do something to it to show what's underneath.
And like what? So what would they destroy? Let me know when you want me to play it.
Maybe hidden treasure inside the painting.
Treasure, but then why not just have the treasure? Why destroy the painting? The question is why do they wait for, and what is it for? Okay, so
it's like wine.
What?
It's like good wine.
Okay, that may be an interesting idea. What do you mean?
I think that what we see is not the real painting. It's underneath there doing something.
Okay, not the real painting, but then you have to come up with a very concrete answer to survive it. You cannot say doing something, right? You have to say exactly what it is about and why do they want to destroy it.
I'm thinking you either have to burn it or, I mean, that was my first thought.
Okay, that's cool.
Yeah.
That's a very cool thought. What the rest of you think, guys?
I'm just beyond lost.
Sorry?
I'm like beyond lost.
You see, guys, that's what we can do. We can play games what, when, where, right? As long as we do mathematics. Soaking up wine, that's a very interesting idea, Carolina. Very interesting. Something that is fermenting, whatnot. All right, let me know when you want me to play, if you have any other versions.
What if they're just waiting for the paint to dry?
So waiting for the paint to dry, but then why destroy it? The question is why, very important, why do you destroy it?
The reason I said it could be a culture thing, because it could have like this person is an army veteran, right?
Yes, but he lives very, very far. I had a relative.
Yeah, I get that. That's why I was like asking. Maybe it's like a respectful thing.
Okay.
You know, sometimes instead of like bringing expensive gifts to a wedding to show, you know, your respects, to show respect for an army veteran in Russia. I don't know. It could,
It's not-
like I
it's
said,
not- you
weird
have to understand,
cultures.
if you want to know where it is, it's very close to China. It's very far from Europe. It's like the end of Russia in that direction. You understand? It's very
Serbia.
far to the east, where this person is. Okay, image interesting, right? So I'm gonna play it, okay, guys? If you don't have any objections, let's see what they argue. Yes, I thought you would mention the Muppets, honestly, right? But they're very grumpy, but very intelligent and actually very witty, you know. All right. They have a lot of fans. You know, this guy has been with the show for 45 years. You understand? They won many games. It's not like one person comes in Jeopardy and everything. I've seen SNL, but not often. Yes. All right. Not often, right? I've seen a few. Maybe some cake. Not not really. Maybe you know what's a pryanik? Have you ever? Actually, if you were in my class, you would have known what's a pryanik. A pryanik is this gingerbread cookie, Russian version.
Конкретно?
You need something concrete?
Конкретно.
Yes, you need to say something concrete.
Ну, больше похоже был
Look at this guy, because he knows the answer. You understand? He's already pissed.
на шоколад, честно говоря.
I think it looks like a chocolate. See?
Шоколад. Господину Друзю не нравится.
Mr. Druz does not like your answer.
Господин Синев, скажите,
Синев.
из каких версий вы выбирали?
Out of what versions have you selected?
Ну, собственно, версия-то была одна, что
We had
это
one version.
нечто съедобное, чего нужно.
Ища.
You understand what it is about? So you destroy it on the dragon year or whatever. So it's a maybe it would be a pig, and I thought maybe some of you Chinese you would know about it, right? It's made of expensive
I
tea.
get it.
It's
Yeah,
made of
like,
expensive tea, and they destroy it on that particular occasion to make tea out of it.
yeah. One of my uncles actually does this. Like, he runs a tea business, and like,
Yeah, you should
I
have
just
known.
realized.
You didn't realize.
Yeah, I just
maybe
realized.
the solution wasn't that great, so you didn't fully
Yeah.
see it. I had no idea, truly. I thought what could be this made of. I didn't know.
So they thought it was cake?
Yes, no, but not them. You see, not this guy, Druz. I mean, I can show you all. Is this guy, this grumpy from the Muppet, you say, right? He sometimes answers questions instantly. He's very smart. He's a lawyer. So he's very smart. The other very smart guy is the mathematician. Actually, both of them, Sydney and this, it's one of the best teams that they have. They're always together, always stand together, always kind of judge the others, right? And there you have the other team. There are several interesting teams there, actually, right? So, and some of them have rivalries. Some of them they sometimes explode in, in very polite, but kind of, I'm gonna invite you to a duel, almost type of language. I said, you are a scum, right, Mister? A line. And they didn't say that. It's a pretty funny episode. It was not played. You understand? They just get angry about whatever arguments they have because they all want to win. Okay, so isn't it cool? All right, guys.